Alright, so this is our third type of naming ionic, and this is ionic with a polyatomic ion. So this is ionic with a polyatomic ion. Alright, so I've got 4 compounds right here on the board. Let me stand on this side so y'all can see it. Alright, so how could I identify that a compound includes a polyatomic ion? So my top 2 compounds over there have polyatomic ions in them. How are they different from the bottom 2? They have multiple elements, right? Specifically, how many compared to the bottom?
3.
3, whereas the bottom 2 have how many?
2.
2. So how could we tell that a compound has a polyatomic ion in it? Well, it's going to have 3 or more elements, because and this is the same list of polyatomic ions that you all have on the back of your periodic table, but if I was to bond a polyatomic ion with another element, it's going to be one of these, so at least 2 elements, plus something else. So it's going to be at least 3 elements. Alright, so how can you identify the compound includes a polyatomic ion? It's going to have 3 or more elements. Now the key reason why we started with that is because you are never going to name 3 things. No compound has 3 names. No compound has 4 names. Alright? All the compounds that we're naming in class have 2 names. Only 2. Alright, so that means on that first one up there, when you look at that compound, you're not going to say sodium sulfur oxide. On the second one, you're not going to say potassium oxygen hydride. There's nothing with 3 names. You can only give it 2 names. Alright, so when we go to name something with a polyatomic ion, the very first thing you need to do is find the polyatomic ion. So in that first example up there, find it. What's the polyatomic ion in it? Zahara, what is it? In that first one up there, what's the polyatomic ion in it? Just the formula. Is it the Na2S or the SO3? What do you think?
SO3.
Yeah, the SO3, which is why I had you guys memorize them, because it should be a lot easier now for you to pick those polyatomic ions out, because you know them now. Alright, so it's the SO3. We found it. Number 2, identify it. So what is SO3? What's SO3? Sulfite, right? It's sulfite. We know SO3 is sulfite. So the last step you're going to do, step number 3, is name it in order. So in that example, I have Na2SO3. So we already identified that SO3 is sulfite, but I got to name it in order. So first I'm going to name Na. So what is Na?
Sodium.
Sodium. And do we ever change the name of metals? Would I call it sodiumide?
No.
No, we just name our metals. So sodium. And then I name my polyatomic ion, which is sulfite. So the name of that first compound is sodium sulfite, because we can only give 2 names. Yes, Emily?
You don't change any?
Nope, you never change any part of a polyatomic ion name. Just like you don't change any part of its formula, you also don't change any part of its name. Yep, Janaya.
So then what about the oxygen? Like, what do you
It's
do
just
with
part of it. It's SO3 is all together. And we just name it SO3 sulfite.
that? Oh, duh.
Mhm.
Yeah.
I'm kidding, I'm kidding, I'm kidding.
Nope, because Na is just in group 1.
That makes sense.
And we only do that for groups 3 through 12. Yep. Alright, let's do the next one. KOH. KOH. So first, find the polyatomic ion. Find it. What's the formula for the polyatomic ion in that one? OH, right? Identify it. What's OH? Hydroxide. Okay, so we have hydroxide here. So now let's name it in order. What is K?
Potassium.
Potassium. Do I need to put potassium's charge in the name?
No.
No, how come?
It's not a transition.
It's not a transition metal, it's just group 1. Remember, we only put the charge in the name if it's in groups 3 through 12 or SN and PB. This one is not, it's in group 1. So it's just potassium. And then we name OH, which we said was hydroxide. So potassium hydroxide. So every compound is only going to have two names. So if there's 3 or more elements, it includes a polyatomic ion. So you find it, identify it, name it in order.
It's pretty easy.
It can be difficult though, which is why I have more examples on the next slide.
Oh, I was gonna say, like, what would you do about, like, CNO?
Well, you would never have cyanide first because it's negative.
Oh.
The only one you could ever have first is ammonia
Why?
because it's the only positive polyatomic ion. Remember, positive always goes first in ion. All the other polyatomic ions are negative, so they'll always go second. Are we good here? Can I erase? Everybody good here?
Yeah, that was
Yeah.
Just throw it.
Alright, now we already did these first two, so let's go to this third one. NH4 3P. NH4 3P. So first, find the polyatomic ion. NH4. It's easy with parentheses, right? Because isn't that the point of parentheses? We put parentheses around polyatomic ions. So when you have parentheses, it's easy to find that polyatomic ion. It's NH4. So identify it. What's NH4? Ammonium. Now we name it in order. Well, this time, ammonium comes first. So we name that first, ammonium. Now we got to name phosphorus. So when we name our anions, we do change their name. Remember writing all 15 on the board? So what does phosphorus become?
Phosphide.
Phosphide. So ammonium phosphide. Alright, look at the next one. NH4C2H3O2. And I bet you someone on the test is going to call this nitrogen, hydrogen, carbon, hydrogen oxide.
Ammonium.
Yeah, there's only ever two names, guys. So if you got lots of elements, you got to turn your periodic table over. Which, even though I had you all memorize it, they're still going to be there for the quiz.
Oh,
That's
Yep, they're still there. So you
So
can
what'd you
still
change?
use this,
So
okay?
what'd you change it to? Acetate?
Yep, so we still have ammonium. And then what else do we have now?
Acetate.
Acetate. So we just have to make sure we name them in order. So what comes first? Ammonium, and then what? Acetate. So it's
Why don't you
ammonium, acetate.
Why don't you change the ending of it though?
No, because we don't ever change these names.
Okay.
We just list them. Ammonium, acetate.
That's not that bad.
Alright, now we throw a curveball in. Alright, so FeOH3. What's my polyatomic ion? OH. And what's OH? Hydroxide. So let's name our metal first. What's Fe? Iron. Alright. Where's iron at on the periodic table? Group 8. It's a transition metal. So what do we have to include in the name? The charge in Roman numerals. So we gotta include the charge. We're gonna have to find that in a second. And then we just name our hydroxide.
So will we always include the charge for 3 to 12?
Yep.
Okay.
Alright, so I gotta uncross my subscripts. So what's my subscript for iron? 1. Alright, so I'm gonna bring that up here. That's -1. And then I'm gonna take my 3 and bring that up here. Is hydroxide a -1?
Yeah.
Yep. So what's my charge of iron? 3. So it's iron 3 hydroxide.
That's still not that bad.
Not too bad. Now I'm gonna give you one that I see as being difficult. Okay? SnSO4. So what's my polyatomic ion here? Sulfate. So I know that's coming last. Sulfate. What's my metal?
10.
Tin. And what's specific about tin?
It's in group 12.
It's in group 14, right? 14, and it acts like a what? A transition metal. So we have to put the charge in the name. So let's figure out this charge. Anyone want to take a guess?
I feel like it, my answer's
6.
too obvious.
It's not 6. Not 4. Not 5.
One?
Nope.
Nine.
Oh, wait,
Alright, so look.
wait.
Now we're just yelling out numbers. Alright,
Wait.
let's go through this.
16.
Oh, 16. Two.
Oh.
Right now, how many SNs do I have? 1.
Number.
How many SO4 groups do I have?
How many, huh?
You have one.
SO4 groups.
What is that? One.
How many of these groups do I have?
One.
1.
Oh.
If I had 4 groups, I would have parentheses with a 4 outside, right?
So it's just one.
Just 1. So I don't uncross the 4. That's the mistake I see
It's
people
really
make.
good. It's really clicking there, Jacob.
Parentheses aren't there, so it like trips you up.
The gears are
Yes.
going.
So when you don't have parentheses around your polyatomic ion, you can't just uncross that number that's part of the polyatomic ion. It means there's 1 of them. That's the number you're uncrossing. So now, is sulfate a -1? No. What's sulfate's charge? -2. So if I double this one, I double this one. So what charge was 10?
2.
10, 2 sulfate. That's the error that I see people make, is that they want to uncross that last number of the polyatomic ion because there's no parentheses there. But that just means there's 1 of them. So you should be uncrossing a 1. Okay? Alright, so now let's flip it and do the reverse. And we're only going to do the first one because I know you guys got this. We've been doing this forever. Looking up the charges and crossing it. Looking up the charges and crossing it. And you know to put parentheses around your polyatomic ions. But when I quizzed you and gave you 4 of them, half the class still missed one like this. Because you forget to put parentheses around hydroxide. That's the most commonly missed polyatomic ion. So, when you have hydroxide, we have magnesium is +2. Hydroxide is -1. When you cross a number over a polyatomic ion, even hydroxide, you have to put parentheses around it. Alright, so many people miss that one that I know how to cross charges. And it's just hydroxide that people miss. So just always put parentheses around hydroxide if you want. Just always put them there. So MgOH with the 2 outside. Okay? That's the one I see people miss the most. You remember sulfate, you remember all the other ones, you just forget hydroxide. Okay?